Hello, welcome back. So, um, um, so let's think about this um, ratio. I mean, basically, it's train a black model to um, determine the weight of the additional you know asset, the positive alpha asset in the active portfolio. Constructed with passive portfolio, right? So in our last session, I explained the meaning of uh, this ratio, information, what they call information ratio. It's actually not exactly not the same thing as information ratio, because information ratio is actually alpha over standard deviation of error terms, the firm specific risks, but it's alpha over uh, variance. So which is like if you think about it, this is the uh, uh, if you remember, it's called price of risk, right? This is market price of risk, actually, and the difference between the uh, Sharpe ratio and market price of risk is simply the difference between variance and standard deviation variance, right? But anyway, I said this isn't exactly Sharpe ratio, but roughly a Sharpe ratio. And the reason, I mean, uh, it's more pronounced using, think about it, using variance in the denominator makes the effect more pronounced rather than just standard deviation, right? Because I've been telling you over and over, obviously, dividing the alpha by the variance would make this ratio uh, clearly uh, more pronounced, like greater than one. If it is standard deviation, you would hardly find a situation where the ratio is greater than one. And having the ratio uh, having the ratio being um, greater than one makes it easier, as a uh, for a metric, as a metric, it would be easier to tell, whether it meets the criteria or not. If it is greater than one, obviously, if the ratio is greater than one, I mean, uh, cost benefit ratio, a benefit to cost ratio or return risk ratio. If it is greater than one, it's easy to tell whether benefit is greater than the cost, right? So that makes sense why we use variance uh, at the bottom. Excuse me. Okay, since my throat is drying up, so difficult to speak. I'm gonna drink some water. Uh, so let's take a look at the footnote, because I put in a lot of time and effort to make this uh, PowerPoint. So why waste any slide? So when see, so actually, before we take a look at it, it makes sense why um, basically, these two are like price of risk, and Google's price of risk, and this is uh, market's price, price of risk. And if you take the ratio of the two, or ratio between the two, and it gives uh, Google's weight in the optimal risky portfolio. So we take calculate this, right? Of course, this is not, this is an interesting thing. Obviously, this is not Sharpe ratio, but we call it rather, more like, that's why I used, you see, that's why I used, roughly equivalent to this symbol, right? Perfect. Um, you can think of this as, squared Sharpe ratio, right? Although it's only uh, and then, but this is price of risk, in other words, the Sharpe ratio of the uh, Google, and the ratio between the Sharpe ratio of Google and the market portfolio, Sharpe ratio of the market portfolio. And think about it. If these ratios are the same, then this number will be 1, right? If these two ratios are the same, the number will be 1. And if this ratio is greater than 1, if the ratio is greater than 1, it definitely uh, the Sharpe ratio of Google is greater than, if the Sharpe ratio of Google is greater than Sharpe ratio of um, market portfolio, then the ratio will be greater than 1. But then here, the thing is, uh, 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 that is not beta adjusted. I mean, I'm going to get to that later. Uh, if this is still positive, right? I mean, the ratio can be, positive, it can be negative. Uh, Positive, but between 0 and 1, negative, but between 0 and negative 1, positive, greater than 1, negative, meaning less than 1. There are many, multiple scenarios, at least 3, 4 scenarios for the possible weight. But the weight will have to be uh, less than 1. Isn't that right? Google cannot be uh, Google's weight cannot be greater than um, the entire uh, risky, uh, uh, you know, uh, entire passive portfolio. Of course, if if the ratio is greater than 1, if this Sharpe ratio of between Google and passive portfolio is greater than 1, obviously Google has the uh, uh, superior alpha. Then you might wonder, why don't we all put all the money into Google? Well, you may achieve, then the thing is, think about it. You may achieve higher Sharpe ratio, but then it defeats the purpose of diversification, right? It's like putting all your eggs in one basket. You don't want to put that. That's the reason for, even if Google is a good company, even if Apple is a good company, Apple's Sharpe ratio, let's say, may not be greater than the market Sharpe ratio, but let's say Apple's Sharpe ratio is superior to market Sharpe ratio. Then are you going to put all your money into Apple? No, that completely um, that completely know uh, defeats, or that completely uh, negates, right? That will completely negate um, the diversification. Uh, the basic tenet. You don't put all your nest eggs into a single basket, right? Um, so that's why the next thing is to adjust this weight for Google's beta. So here, this formula, I mean, this notation is, um, that star, that asterisk is, means, adjusted, weight of Google, and that adjusted weight of Google is, basically, Google's weight out of the um, uh, entire weight is one. Isn't that right? The total of the weight is one, and plus weight of Google, unadjusted weight of Google, times one minus uh, beta of Google, right? And once this is found, then the weight in the passive market portfolio is one minus weight of Google. But let's think about the meaning of this. What's the meaning of this? I mean, one plus, um, and the meaning is not that difficult, because if beta is uh, positive, I mean, Google would have a positive beta. Most companies have positive beta. I've been telling you, there are some companies that have negative beta. Um, of course, even if they have negative beta, the negative beta would be between 0 and -1, right? You wouldn't find any, you know, uh, it's unreal, it's unrealistic uh, to find a stock that has, completely, -1, beta of completely -1, or greater than, negative, or less than -1. I mean, like negative, unrealistic. I'm not saying it is, impossible, but it is unrealistic. And then, suppose, uh, Google's beta is 0.5. What's it going to be? This is going to be, 1 minus 0.5, 0.5. So, uh, uh, weight of, Google will be uh, 0.5 times, weight of Google. So, whatever the weight of the whole thing, it will increase by adding Google, it will increase uh, the entire portfolio, though. It will increase the denominator to 1.5. I mean, of course, that doesn't mean the uh, total weight will be 1.5. It's just to find the ratio, right? Find the weight. I mean, think about it. Uh, unadjusted Google's weight over, if it was 0.5, right? Uh, Not 0.5. Let's say uh, whatever it may be. Uh, But if it is 0.5, after adjusting for beta, 0.5 or 1.5 would be like, 0.333, right? So then, Google will be, the weight for the Google will be 0.33, and, weight for the passive portfolio will be, 0.67, right? And that's, basically the idea. Now, of course, uh, we can we can delve more into this weight schematics, right? Or weight skim, right? How because there are um, different four possible ranges of beta values. First of all, what if beta was greater than 1? Before that, let's know some of the weight, all the weight will have to be 1. And adding Google will increase the weight by weight of Google times 1 minus beta. So in other words, this is the explanation behind it. So if beta is less than less than 1 means what? We'll have to break it down further. Less than 1 means between 0 and 1, right? Of course, less than 1 also means negative range. What if Google's beta is negative? And we'll have to think about the range where beta falls between 0 and -1, and then even when beta is less than -1. Okay, and so this is uh, third case, uh, third possibility and fourth possibility, but number 3 and 4 are unrealistic. And why they are unrealistic, I'm going to explain it later. Um, so if beta is between 0 and 1, I already explained that. This will be this weight of beta adjusted weight of Google will be between 0 and 1, and 1 plus beta adjusted weight of Google will be greater than 1, and the whole fraction, and bringing we bring it back to this, right? And then this will make the adjusted weight of Google something like something between 0 and 1. Okay, and then if theta is greater than 1, the sum of all the weight will decrease slightly by adjusted, beta adjusted weight of Google. This is the case, this is old thought experiment, right? If beta is greater than 1, this number will be negative. Okay, this number will be negative. Weight of beta will be negative. Think about it. If it's greater than 1, 1 minus something greater than 1, it will be negative, right? And then, that means actually shorting Google. If, weight of Google is negative, that means shorting Google. But, short there, but, So, but even though this is, so if this is, negative, right? One plus, uh, one plus, beta adjusted weight of Google will be, uh, between -1 and 0. Uh, and then if it is further, I mean, let's say if beta is greater than 2, greater than 3, then, this will become completely, less than -1. But that case can be ruled out because um, weight of Google can not be, greater than uh, weight of Google can only be, even if you short Google, the weight of Google can be only, between -1 and 0, not, less than -1. Okay. Uh, you cannot short Google by more than the, the amount you put into a passive portfolio. Okay, that's what it means. And then, if beta is between -1 and 0, and then, 1 plus beta adjusted, weight of Google would be 2, greater than 2. If it is even less than -1, greater than 3, and these these scenarios are unrealistic because weight of Google cannot be greater than the weight of the entire optimal risky portfolio, right? So only two scenarios are uh, plausible, and then under those assumptions, basically. Um, uh, and I told you this is basically uh, the ratio of Sharpe ratio, right? Uh, the ratio of two Sharpe ratios, Sharpe ratio of Google and the Sharpe ratio of the uh, passive portfolio, and of course, Sharpe ratio of the uh, uh, Sharpe ratio of this portfolio should be uh, greater than the passive portfolio. Otherwise, there's no benefit. Makes sense? If there's no benefit of constructing an active portfolio by adding Google, if the Sharpe ratio doesn't of the entire Sharpe ratio of the Google is not greater than the Sharpe ratio portfolio, passive portfolio. Um, since think about it, alpha is alpha of Google. Alpha of Google is the excess return on Google when excess return on the market is 0, right? The Sharpe ratio of optimal portfolio can be expressed as exactly the information ratio of Google. Why? Think about it. If excess return is 0, what does that make this? Right? You get it? If excess return Again, my freehand is really not. I mean, it's steady. It's just that the mouse is not really doing a good job. Now think about it. If access return is 0, right, and that's when you have, alpha of Google, and this whole thing is nothing. I mean, this thing doesn't even exist, right? Um, you're not even, you might say, oh, if this is 0 and the whole thing, the denominator is 0, how can you divide by 0? No, don't divide it. I mean, don't think about, dividing it by 0. I mean, then it stands alone, right? Um, the Sharpe ratio of Google, Sharpe ratio of optimal uh, uh, risky portfolio is simply the Sharpe ratio of Google, right? Therefore, um, uh, you know, um, Sharpe ratio squared of optimal risky portfolio uh, minus Sharpe ratio of asset portfolio is simply the Sharpe ratio squared of a Sharpe ratio squared of Google. Now, so if adding Google leads to significant um, uh, information ratio that is greater than 1, that means, simply benefit outweighs cost. Let me, doesn't have to be in a participle form. Just, benefit outweighs cost. So the benefit to optimal risk portfolio's Sharpe ratio is solely derived from adding Google to the optimal portfolio. If Google has um, uh, this is a bit not just positive alpha, but positive and uh, significantly good alpha, high alpha, positive and significantly positive alpha, then the Google's uh, uh, information ratio. This is called information ratio, right? Yeah, Google's information ratio must be greater than 1. I mean, it means, as I think I should have put, like significantly positive, right? Significantly has. I'll put it later. Let's do it now. Significantly positive. Right? Significantly positive. And then that translates as sole source of benefit to Sharpe ratio of the optimal risky portfolio improvement over Sharpe ratio of Google. Okay, in other words, benefiting from adding Google, right? And then and this information ratio determines improvement over passive benchmark. So the portfolio portfolio weight is basically determined by the total portfolio's weight is, think about it, the total portfolio weight is sum of all the in other words, weighted sum or weighted average of all the information ratios. If you think about it, all the assets in the portfolio, right, as their own information ratio, and portfolio is a collection of or weighted average of all these information ratios, right? So I guess I'll have to cut the video here and continue. It's more, continue in the next video because it's more, involved and more complex concept. But it's all ratios. I mean, it's not really, as long as you're staying focused and analytically, sharp, right? You see why what's the reasoning behind all these ratios, right? Anyway, since it's going to take some more time, I'm going to have to cut up the video now and then continue in the next session. Stop recording.